Hey everybody, this is Alex Merced, and welcome to another episode of Gnarly Data Waves. We're going to be talking about getting started with Dremio data reflections, learning about the secret sauce of the Dremio platform, and giving you that nice, crisp performance on your data lake and data lakehouse. But one thing I'd like to ask you is to go out and try out the data lakehouse. Try out Dremio, get hands-on, head over to dremio.com, click that test drive button, and you know, experience it for yourself. Okay, also, make sure you get an early copy of Apache Iceberg, the Definitive Guide, a new book from O'Reilly, slated for release early next year. You can get yourself an early release copy by scanning that QR code right there. And yeah, check it out. The first couple chapters are now available with lots of great information, more to be added as we go. Okay, and plenty of more Gnarly Data Waves episodes coming up in the coming weeks. Next week is going to be simplifying data mesh with Dremio's Open Data Lakehouse. After that, best practices for building a data lakehouse on ADLS, and then versioning data in the data lakehouse. File, table, and catalog versioning. Okay, but keep in mind, Dremio is going to also be working with AWS and Tabular on the following events in Chicago, New York, Toronto. So if you're in any of these cities and any of these dates, make sure to be there for a good time. And also, Dremio will be visible at many of these conferences around the world, including Big Data London, coalesced by DBT, the Data Festival, Big Data and AI, Big Data and AI World. So if you're at any of these events, go check out the Dremio booth, pick up some swag, and say hi. And with no further ado, we're going to get on to our featured presentation, getting started with Dremio Data Reflections. Today with Tiong Lee, who is a Senior Director of Engineering at Dremio. Tiong, the stage is yours.
Thanks, Alex. Hey, everyone. In today's episode, we'll be covering how to get started with Dremio Data Reflections. Joining me today is Tiong Lee, who is a Senior Director at Dremio for the SQL Planner and Reflections engineering team. He has over 20 years of experience in big data, leading analytics teams, developing software for query engines, and building enterprise data warehouses. And in today's agenda, we'll be covering the traditional data architecture and some of the problems that came with it. And we'll be going over the Open Data Lakehouse with Dremio, reflections, and then giving a demo to show how it works. So companies today want to democratize data, but the question is, how do we do it? As a line of business leader, you may have data that's sitting in object stores such as cloud data lakes or on-prem data lakes such as Hadoop. And then you may also have other data sources sitting in relational databases on-prem or in the cloud, right? So an example here, you may be running a customer 360 project to accelerate new business opportunities. Just an example here, if you're in insurance, you want to drive insights quickly before policies lapse, which increases the hit rate for cross-sell and upsell opportunities. And so what you're trying to do here is reduce the time to close an insurance policy from a month to days. And in this example, everybody wants access to data. So these will be your data consumers. But the problem is data volumes are also exploding, meaning it's coming in at an increasing rate. And so with this, you need to keep in mind some of the security risks that comes with, ingesting data and sharing data. So you have to be able to meet compliances that are set out by your company and in specific regions. And then your data engineering team may have limited resources. So you may have a small team of data engineers, but the business requests may be more than what your team can handle. And so what are your options? So typically we've seen in traditional data architectures, the data warehouse has been the de facto solution. But the problem is this data architecture is very complex. It can be very expensive, meaning all your data can be locked in to the specific vendor. It's hard to secure that data because once that data lands into the warehouse, to get that data into the hands of the end users, you have to copy it out into something like a BI extract or cube for self-service analytics. Across these enterprises, you will rarely find one data warehouse, right? There will be multi-cloud use cases. These data warehouses may be competing with each other. So by design, they don't talk to each other. And so if you have data that's sitting in, for example, Snowflake, and you have another set of data that's sitting in Redshift, it may be hard to unify those data unless you copy it back into object store or bring it all onto one data warehouse. And so with this, you really start to lock in your data, and then it makes data very hard to access outside of the engine that's associated with that data warehouse. And so what we see from customers is that they copy the data from the warehouse out into offline copies, BI extracts, or into CSV files, which causes inconsistent data, and it's a data governance issue. And so I'd like to introduce you guys to the Dremio Data Lakehouse. With Dremio, we serve as a unified access layer for all your data. We're a data lakehouse query engine, so we can access data that's sitting in S3, ADLS, and even Hadoop. But we also understand that customers may be at different stages in terms of their data platform maturity. So some organizations may have recently migrated to Snowflake, so they don't want to migrate data off the warehouse. And so we tell them that's okay because you can start unifying data sitting in Snowflake with data that may be sitting in your data lake. And so with Dremio, you can actually use us as a semantic layer on top of a query engine and to create self-service analytics for your end users. And so you may be able to create domains into, sales, marketing, supply chain, product, HR, and finance. These are examples. So you can create views of all your data without additional copies. And powering our semantic layer is Dremio Reflections. And now I'll hand things over to Tiong so he can talk to you a little bit more about reflections and how the technology works over at Dremio.
Thanks, Tony. Now that we've generated enough buzz about data reflections, let's dive into understanding what it actually is. Here's a concise definition that I always use. Data reflection is a query acceleration technology in Dremio that enhances query performance by utilizing user-defined relational caches. These relational caches are officially referred to, as you have guessed, reflections. Think of a reflection as a materialized view like cache, which consists of a query plane and its associated materializations. The key distinctions between a reflections and a materialized view is that users don't directly reference reflections in their queries. Instead, reflections functions more like an index, and the Dremio query planner automatically leverages them to accelerate queries whenever possible. To better grasp the concepts, let's take a look at the following diagram illustrating how a user configures in a reflections and uses it to expedite a query. In order to take advantage of query accelerations, user log in by defining a reflections, which essentially serve as a query plan. This can be done through Dremio user interface or via SQL commands. In the diagram, you can identify the reflection setup indicated by the highlighted yellow text. Once the reflection is defined, Dremio takes charge of managing the materializations process, also known as refresh for the reflections. This involves executing the reflections query plans against the data sources, either in a complete or incremental manners, depending on the configuration of the sources. You can observe this process represented by the dotted line and the green yet highlighted text in the diagram. It indicates that Dremio automatically handles the management of the relational caches. When the query is submitted to Dremio, it evaluates whether the query can be accelerated using the configured reflections. If acceleration is possible, Dremio utilizes the materializations of the reflections and fulfill portions or all of the queries and bypassing the needs to perform the computations. This enables Dremios to deliver fast query performance, often within sub-seconds response times, which is particularly valuable for BI dashboards and sometimes ad hoc query as well. So let's dive deeper into how reflections accelerate queries. When a SQL request is received, the query plane is analyzed against all the reflections that could potentially match the query. In the provided diagram here, you can observe that there are two reflections that perfectly match fragments of the query plane. This implies that we can substitute these plane fragments with the pre-computed results stored in the materializations, effectively bypassing potential time-consuming processing and significantly speed up the query execution. As the diagram shows, the resulting accelerated plane is much simpler and more streamlined, leading to a faster query execution. In certain cases, the query plane might entirely replaced by a materializations, eliminate the need for any additional computation altogether. Let's walk through some example queries that data reflections can accelerate. Suppose we have two tables, order and store, representing purchase and physical stores, respectively. The relations between them is captured through the store ID columns present in both tables. We define an aggregations reflections on the order table, materialize the sums of total columns grouped by store ID. You can see the logical definitions of the reflections in the highlighted yellow text above. Therefore, the materializations of the reflection involve a query on the order table, summing up the total column. Now, let's examine the first query that we receive. This query is essentially identical to what we have defined in the reflections. As a result, it will be entirely substituted with the select statements from the materialized data stored in the reflections. This means the query can be directly served from materializations, eliminating any needs for additional computations. Next, let's consider the second query. It aims at retrieving the total sales for each of the stores alongside with the store names. The query optimizer will identify that it's feasible to join the materialization's order ID with the store table in order to perform the grouping. This enables the query to be accelerated by leveraging the reflections. If the store name is unique, this might result in minimal or no aggregation computations during the query execution. The third example here is more interesting. It's similar to the second example, but in this case, the query further aggregates the pre-computed sums of each store to obtain the total sales of each state. The reflections will still speed up the query, but assuming there are so many stores in the same state, the query execution will still do the like aggregations to get the total sales of each state. Example 4 is a straightforward one. Since it only requires the sum of all the total columns, the reflection will be utilized to compute the total sales figures efficiently. These are just a few examples that illustrate the principle of reflection query accelerations. The actual support for query accelerations is much more sophisticated, and we will explore more of its capability in the demo. Now you know how reflections works. You may be focusing on the advantage it offers compared to a traditional approach of managing data. By examining the diagram, you can observe that in the traditional approach, numerous physical created derived datasets are directly exposed to the data consumer. On the other hand, the new approach allows the constructions of a cleaner and more semantically organized logical layer, which leverage relational caches to enhance performance. The advantage of reflection approach can be summarized as follows. First of all, it makes everything simpler, as you will have a cleaner semantic layer, reducing the number of datasets that you need to manage, as well as data consumers need to deal with. Second of all, you have more flexibility because you can optimize your relational caches at any time without impacting the semantic layer. This allows agile adjustments and fine-tuning to meet evolving business needs. Thirdly, you will reduce your compute costs as reflections can be shared among different integration points, allowing collaborative optimization efforts. They are not tightly coupled to any integration point, allowing for broader optimization across the organizations. Lastly, your data lakehouse will be easier to manage as you can significantly reduce the number of pipelines and derived datasets. In summary, the reflection approach leads to a more efficient and optimized data management process, enhancing the overall user experience and enabling organizations to make the most out of their data assets. Let's shift our focus here to the various types of reflections in Dremio that can be used for different use scenarios. The aggregation reflections is specifically designed to accelerate queries involving aggregations. The materialization is often smaller than pre-aggregated data, and it can significantly speed up the aggregations process, just like we saw in the previous example. However, it's important to note that the performance bottleneck in a query doesn't always revolve around aggregations. This way, raw reflections come into play. A raw reflections can be used to speed up any arbitrary dataset or view. Some of the use cases of raw reflections includes speeding up joins, handling inefficient data format like CSV or JSON, or accelerating slow data sources. The third type of reflection is external reflections. If you already have an existing pipeline that creates derived dataset, you can inform Dremios about the relationship between this dataset using external reflection mechanism. The query planner then will be able to use your derived dataset to speed up your query whenever possible. Now it's about demo time, and before we do that, I want to introduce us to the dataset that we'll be using in our demo, namely the TPCDS dataset. We will focus mainly on the store sales tables, which has the keys that points to various dimension tables, including store, customers, items, and date dimensions. On the screen, you can see the Dremio web console. I'll probably spend a quick minute explaining the various areas and then show you a few sections of the screen that we'll be using for our demo. The first icon on the left represents the dataset management area. Here you can add new sources, as you can see from the lower navigation here. And we have S3 Hive Metastore as well as a Snowflake source. These sources represent connectivity that we have established in order to query data from them. Some of them contain physical datasets. They are all remote in their respective sources. On the top, we have spaces, which we can use to define our semantic layer. You can create space, add folders within space, and create a virtual dataset, which essentially is a view of other datasets. The second icon here is our SQL runner, where we can write our SQL. Let's create a new runner in the tab for our use later. The third area will be the job history page. And lastly, this is a configuration page. And there's the sections in the configuration page that is relevant to this demo. So let's open that in a separate tab. All right, this concludes our quick intro to Dremio UI. Let's run some queries. I've created a few new SQL scripts here for the purpose of this demo. The first script is running through some of the queries around store sales. We are getting the total sales of the top 10 stores, top 10 states, and top 10 cities. Let's give it a run and I'll explain what it is about. The diagram from before shows you the relationship between them. The store sales in the store tables are joined by a column called store SK. So some of these queries need to use a join key to join the data before the aggregations. We will use the reflections on the store sales table that includes the store SK key to speed up the aggregations. Now let's get back to our SQL runner.
So this run takes between 1 to 9 seconds.
We can look at the profiles of one of the queries to see what happens under the hood. Let's look at the slowest phase here. It is a join between the stores and store sales table and involves 2.9 billion rows of data from the store sales table. No wonder it slows. Let's see if we can speed this up by creating a reflections on top of it. Let's go to the dataset definition page for store sales. You can see I already created a few reflections here. It includes date SK and store SK as the dimensions, and the sum of sales, which is the total sales price for the item. Even though we only need store SK dimension in our aggregations, let's create this for now. While we wait, I should point out that each measure is customizable. You can see we can do sum, count, and also some of the interesting ones like estimated distinct values. Okay, looks like the materialization is done. Let's try to rerun the query. As you can see, all of them now are accelerated. Let's take a look at the profiles of one of the queries again. The profile shows that the reflection is picked up by the query. And from there, we can also see that the rows of data that it needs to go through are significantly less because we're reading the pre-computed sum from the materializations. Now let's try to create another reflection that only includes a single dimensions, the star SK.
Because all the query doesn't need the date dimensions.
Now let's run the query again. So still 1 second for most of the query. Let's look at the profiles again. As you can see, the query planner picks up the new reflections, and the reason is because it has much lower cost. You can also see in the visual profile that it has about a few hundred rows of data, which is much less than the 2 dimensions reflections.
There are a few key learning here.
We show how easy and flexible it is to add reflections to optimize slow queries. We also show that the query planner is smart enough to use computational costing to find the best performing reflections for your queries. And the same reflections are accelerated more than one queries. In fact, let's take a look at our demo script tool, which contains more complicated examples.
Let's run these queries and we can talk about them individually later.
The first query and second query add a filter to get the top stars in a specific state. This will just use the same single dimension reflection that we just have, grouping on the star SK. The third query just computes the total sales over the years, and the fourth is doing the month by month growth over the years. Now, given this relates to date dimensions, the first reflection that we created, which include the date SK, will be used for the queries. Lastly, we have a query that computes the month sale for the top 10 stores. Given this involves both the store dimensions and the date dimensions, the 2-dimensional reflection will be used. What we are trying to show here is no matter how complicated your query is, the query planner will see through the query forms, break it down into the essence of relational algebra, and choose the right reflections for your query. Now, let's switch gear to see some of the applications of raw reflections. Here's some queries into the sales data. Let's run the query. While it runs, let's look at the definitions of all sales view. As you can see, it's actually a union of the other sales datasets. It turns out that our fictional TPCDS store has a few different departments that sells the product on the web and through the catalog. The web division is using Snowflake for the sales data,
while the catalog department is using Glue.
Dremio supports query federation across all these data sources in order to get you the result. Now let's look at how the queries are running. Looks like our query to the Snowflake dataset hasn't finished. Maybe the Snowflake warehouse is too busy or undersized, or maybe it's just slow in general. This is where the raw reflection might come in handy. We can use the raw reflections to pull the data from the data source as materializations, so we wouldn't be relying on the external systems as much. It will also reduce the cost of other expensive external systems. I'll show you how this can be done. Here you can configure the raw reflections on the source dataset itself, and you can also configure how the dataset will be refreshed. We support full refresh as well as incremental refresh using a schedule. I'm not going to save these reflections here, as it will take hours to run due to the volume of the data. Here we show you some of the use case of raw reflections. one thing to keep in mind is raw reflections can also be used to model complex queries, and the query planner will utilize it when the raw reflections measure the query algebraically, just like aggregations, reflections, or external reflections. Now let's shift our focus to external reflections. We can look at another data set we have in Snowflake. It turns out that our web department is doing some ETL to create a derived data set in Snowflake, which aggregates the sales data based on the demographic dimensions. We want to be able to tap into the data sets so we are not doing the redundant aggregations here. The first thing we need to do is define the relationship of the data set virtually in Dremio. You can look at the view definition here, which define the type of aggregation that will represent the remote data set. Here you can see the aggregation is directed towards the web cell SF table because the remote data sets only contain aggregation that is done towards web cells. Now, having established that relationship,
we need to create the external reflections, which I have done before.
There is no materialization being done because everything is done externally. Let's issue a query that queries the demographic data. We can see from the profile that the reflection is picked up by the query. Now we can use the external dataset as a reflection cache that can speed up many different queries. In the last sections of the demo, I want to show how we can integrate Dremio into Tableau dashboard. Here, I have logged into my Tableau environment and started to work on a new workbook. We can look at the configure data source here. You can see only a few concepts are being exposed in Tableau dashboard. But with that, I can build all these fancy charts because the reflections accelerate all the queries generated by Tableaus around the data table that we have exposed to it. The integration point is much cleaner and stable because of the semantic layer and reflections. To end my segment, I want to bring us back to the diagram that we were looking at before, comparing the traditional way of managing your data lakehouse versus the better way that Dremio is advocating. The demo walks through the simplicity, flexibility, cost saving, and ease of management of the new approach using Dremio, semantic layer, and data reflections. With that, I'll pass back to our host.
Welcome back. Welcome back. Now it's time for the Q&A portion. Hopefully you guys enjoyed that amazing presentation on what is an amazing feature in Dremio. That the more I learn about reflections, the more, it's just one of those like mind blown type when you start thinking about really the implications and the use cases. But again, this is the time of the show where you can start putting in questions in the Q&A box. Okay, so head over there to the Q&A box and leave any questions. We have a few questions ready to go, so let me just get to those. Okay, so Tiong, does Dremio have materialized view support?
So Dremio doesn't have official materialized view support, but I think a view with raw reflections that has all the views is essentially a materialized view. That means whenever a query refers to that view, we will actually use the materializations automatically by default. And better than that, we will still find potential reflections that can accelerate your queries, even though you just refer to that view. So that means reflection is strictly better than materialized views in terms of performance. And on top of that, your raw reflections can be used by other queries that actually that query similar patterns to your materialized view.
Okay, next question. Does reflection materialization require computing and storage costs?
The reflection refresh require proper resourcing of compute and long-term storage. And it's probably no different than your typical pipelines that create derived data set. And one of the coolest things though is a reflections refresh can be accelerated by other reflections during the refresh. I know it's a little bit kind of tongue twisting, but there's the optimizations. For example, if you have a daily sales total reflections, it'll be used for weekly sales total reflections or yearly sales reflections internally during the refresh. So your data operation will always be most optimal in terms of efficiencies and cost.
Okay, and this next question from John Farmer. I am curious around the potential cost savings when using Dremio with Snowflake, for example. Do you have any point of view on the order of magnitude? I believe both are priced based on usage. So before, Tiong, before you speak on the reflection side of that, I do just want to mention one thing, that when you're using, let's say, Dremio, you get additional cost savings, not just because of many of the things that Tiong's talking about regarding reflections, but there's also this other technology called the columnar cloud cache. So when you're dealing with a lot of the calls and fetching of data on S3, that C3 cache is caching a lot of that microblocks, files, file just columns, in order to basically minimize a lot of the cost of actually fetching the data from S3, along with just sort of like the savings and from performance from having that compute setting up. But with that, I'll let you elaborate, Tiong, on any other kind of cost savings.
I think we have published few articles around it. I don't have the links right off my head, but I think we will actually kind of like post it maybe after. Do you know there's any communications afterwards that we can kind of point to those?
Yes. So generally what will happen is that after this is done, we'll post the recording within like 24-48 hours. Now on dremio.com/gnarly-data-waves, that's where you can find one place where you can find all the old recordings. There we actually post the Q&A, a document with all the question and answers and any additional resources that we wanted to add in that document. So yes, and that goes for any previous presentations as well. So dremio.com/gnarly-data-waves. But bottom line is there are many levers that Dremio has for cost savings relative to using other places. That one, the compute and storage itself when you're using Dremio in a lakehouse is generally cheaper, but also again the way it optimizes the uses of that compute and that storage as well. Next question: can reflections be used for ETL, as in the talk you are moving data from external sources? Where is reflection materialized stored? What is the format? And can it be accessed by other systems?
So we do have some customer actually kind of like using reflections as ETL pipelines. Basically, it's just kind of like point reflections to a specific data and just kind of pull it over to Dremio. The reflection materialization is stored in cloud storage as NESI or Iceberg data, and currently it's not accessible by external system, but you can only kind of like access it through query engine, through a Dremio query engine. But I think that in future they might change. Who knows?
Okay, question number 4. We just migrated to Dremio now, but our system is quite complex and hasn't used reflections yet. Where do we start?
It is true that when you use Dremio, you still use your data systems in the traditional way. Basically, the usage of reflections is completely optional. In the semantic layer and reflections is a paradigm shift that can take some time to get used to. So if you already have existing system, you should start by taking a smallest steps and just kind of like take a smaller isolated area and migrate it to start using new way of managing it using reflections. Once you get comfortable with reflection usage, you should envision how it can work on a larger scale for your data warehouse, and then plan for a larger refactoring with your data workflow. But I think in reality, a lot of time you'll find it, most of the time is actually a simplification of your existing data processes, integrations, and the usage for the long haul.
My bad, I forgot to unmute myself. But bottom line is, everyone take a few more seconds if you have any additional questions you'd like to put in the question and answer box. But I mean, again, I want to say thank you, Tiong, for being here this week. That was an amazing presentation on a great topic. Definitely gave me even a further deeper understanding of reflections and how it can basically, save people improve performance, basically, improve performance, improve the simplicity of your data pipelines, and just overall just make working with your data a lot easier and a lot faster. Definitely lives up to that whole Dremio, the easy, open, fast Lakehouse mantra. Okay, so I just want to say thank you again for coming in. We look forward to having you on the show again in the future. Again, same time every week. every Tuesday. And again, we post this again online, so you'll be able to access it on Spotify, on iTunes, on YouTube at dremio.com/YouTube. And again, over there at dremio.com/gnarly-data-waves to find all the previous episodes. So keep coming back every week. Again, thank you, Tiong, and thank you very much.
Yeah, my pleasure. Thank you.
Have a great day, everybody.
Bye-bye.